So I'm going to walk through the old practice test that's on Canvas, just to verbally go over the solutions, even though I know that you have a copy of the solutions on Canvas. Sometimes it's nice to hear explanation. So for question number 1, identify the acid, base, conjugate acid, and conjugate base of the following reaction. The way that you would do this type of problem is you start with whatever is first. So I'm starting with H2PO4. Then you follow it through the reaction and you look for the thing on the product side that most closely resembles H2PO4, just in terms of their molecular formula. So we are going to choose HPO4 2- because that is very similar to H2PO4, and then we are going to do the same thing for NH3. We're going to connect it to NH4. So what we've done there is connected the conjugate pairs, the acid and its conjugate base, the base and its conjugate acid. Now we have to decide which is which. And the way that we do that is through the definition of an acid and a base. An acid is a substance that donates or loses or gives up an H+. So its number of hydrogen atoms goes down, and then its charge also decreases by a +1. It loses +1 charge. And the base is the opposite, so it is the thing that will gain the H+. So the base will add a hydrogen and the base's charge will go up by +1. So when we look at H2PO4 minus turning into HPO4 2-, we can see that it has lost a hydrogen, which makes it an acid, and its charge has also dropped from negative to 2 negatives. The charge has gone down. So that makes H2PO4 the acid. And the acid always turns into what we define as the conjugate base. NH3 then is going to be our base. When we look ahead in the chemical reaction, we can see that we go from 3 hydrogens to 4 hydrogens. We go from no charge to a +1 charge. So NH3 is the base, and the base turns into the conjugate acid. And just to also give you a way to double check, on each side of the reaction, so on the left side and then also on the right side, you should have 1 acid and you should have 1 base. 1 acid and 1 base. You can't have an acid plus an acid or a base plus a base. You got to have 1 of each. And then either on your left side or your right side, they'll both be conjugates. So that wherever you end up putting your conjugates, the conjugates are together on the same side of the reaction. And conventionally, we write the conjugates on the right-hand side. Write the formula for the conjugate base of HSO4-. We're looking for the conjugate base of HSO4-. So that means we're thinking about this as being an acid. And if it's being an acid, that means it's going to lose a hydrogen. So the conjugate, let's write that down. So it's going to lose H+. So the conjugate base is going to have 1 less hydrogen, so it'll be SO4, and it's also going to lose a positive charge. So it's going to go from -1 down to a -2 because it's losing a positive charge. Calculate the pH of 0.052 molar HNO3, which is a strong acid. So for a strong acid, whenever you have a strong acid, the molarity of the acid is going to be equal to the H3O+ concentration for that acid. We walked through an explanation of why. It has to do with the acid doing a total dissociation or complete reaction. pH is the negative log of the H3O+. Since we're dealing with a strong acid, we know exactly what the H3O+ concentration is, 0.052. And that pH is 1.28. calculate the pH of a strong base. For a strong base, similar to a strong acid, the molarity of the base is going to be equal to, ooh, that's not the best way to write that. The molarity of the hydroxide ion concentration of the base is going to be equal to the OH minus concentration, which we'll use to calculate pOH. So pOH is the negative log of 0.36, which is 0.44. pH plus pOH equals 14, so the pH is 13.56. And the only time that you have to be kind of careful with strong bases is that there are some strong bases that have two OHs on them. Like you could have this guy right here. That's a strong base. So let's say we had a 1 molar, I'm going to move this, get it out of the way. Let's say that we had a 0.1 molar barium hydroxide solution. The OH minus concentration of this solution is not 0.1 molar because there are two hydroxides in every molecule. The OH minus concentration of this solution is 0.2 molar because there are two hydroxides in every one of those molecules. So you got to be careful if you're dealing with something like barium hydroxide that has two OHs in it. pOH of a solution, question number 5, the pOH is 1.88. Is this acidic, basic, or neutral? Well, the pH scale is based on the pH, not the pOH. So if the pOH is 1.88, the pH is going to be 12.12, which is very basic. Provide the formula of any strong acid other than nitric acid. We've got hydrochloric, we've got hydrobromic, we've got hydroiodic, we've got sulfuric acid. Those are the ones off the top of my head. You've got a whole list of them. Predict the pH. Predict, not calculate, the pH of a solution of sodium nitrate. So this is the question that's asking you to understand the acidity of the cation and the anion in this solution. Sodium nitrate is made up of sodium ions and nitrate ions, and here you need to ask yourself, with cations, remember cations can either be acidic or they can be neutral, and anions can either be basic or they can be neutral. So here you want to go to that list of what does it mean to be an acidic cation. Is this one of the acidic cations? Neutral cations are all the cations in group 1A and group 2A, so that means that sodium, because it's in group 1A, it's neutral. So sodium is not gonna make this solution acidic or basic. Nitrate, I gave you a list of the neutral anions, and nitrate, NO3-, it is also one of the neutral anions. Because the cation and the anion are both neutral, the pH of this solution is also going to be neutral because neither of these are acidic or basic. They're both just neutral.